Hello, this is Todd Danielson, editorial director for Informed Infrastructure. Today I'm in Denver at the GeoWeek Conference. And joining me now is Dr. Dominique Meyer, the CEO and founder of Looq AI. So thanks for talking to me today. Can we start by introducing yourself, providing some brief professional and educational background information?
Real pleasure meeting you, Todd, and thank you for taking the time today. Dominique Meyer, founder of Looq AI. Really excited to be here at GeoWeek today. My background came out of UC San Diego a few years ago, getting my PhD in computer vision and AI. Was developing a lot of exciting technology for the self-driving vehicle space, and that's how I found out about the opportunity of how we can build cameras and AI to build a better future. So we founded Looq in 2021 with the goal of digitizing our built world. Along the way, I had also helped build a technology stack at a number of applied computer vision and AI companies, both in the medical space as well as the consumer product space. So very excited to bring that knowledge and expertise to Looq AI.
All right, so you mentioned a little bit about the goals. So can you give me just a brief explanation of what the product does, again, what the goals were, and how well you think you're coming along on meeting those goals?
Absolutely. So Looq AI is really targeted about digitizing our built world, right? And we've built a technology stack that allows utilities, engineering companies, surveyors to digitize the world efficiently, right? And our product really is based around a camera solution that allows them to very quickly capture the data in the field they need to be able to digitize it, right? At a geometric accuracy that is survey grade, and then with the intelligence piece to be able to answer downstream applications. And to date, we've spent a couple of years developing this incredible technology that is really changing how quickly and efficiently we can digitize the built world.
So it talks about automating the creation of 3D digital twins. So tell me a little bit about the digital twin aspects, how that they're built from the cameras, and even a little bit about how you're using cameras as opposed to LiDAR or other sensors and lasers that are also out there.
Yeah, so digital twins, I think we're at the nascence of the industry and seeing how they can actually be used for different operational tasks, right? And in our industry specifically, there are a lot of exciting drivers that we're beginning to see. So what's unique about the way we're using cameras is it gives us an vantage point in terms of spatial resolution, right? We're talking about 100 times the ability to capture faster and better data compared to some of the laser systems out there, right? So we describe ourselves, right, as a merge between what is traditionally known as a total station, as a differential GPS, and a LiDAR into one very compact, price point effective unit that now makes it attainable for every field crew out there to be able to capture the data they need. And what does that mean in terms of digital twin? Well, what this means is that we can very quickly and repeatedly update that information that is known to document the digital twin, the as-built of the assets we're scanning. What we pride ourselves at Looq is the AI intelligence piece. And this AI intelligence piece means that we can add dimensionality, different layers to the complexity of this data. And I want to dive into a little bit more detail into this, right? If you look at a digital twin, many of us may know this as a 3D model. Some of us may know this as a set of sensory overlays onto that model to document what is there, right? In the industrial space, in the civil space, and for our case, very much in the utility space. Where Looq really is focused on is being able to provide the asset intelligence piece, right? So how do we now efficiently at scale go from just a 3D model into understanding what that 3D model contains, into understanding what does that mean to operational implications. One example I want to mention are, for example, distribution power poles, which is one of our initial focuses at the company. Being able to automatically detect a material type, whether there's a crossarm that's failing, whether there is a certain conductor that is too close to a vegetation instance, right? All of these things allow now these engineering companies, these utilities, to actually act upon the data that is used. And that's what we believe is the future of intelligence in the digital twin space.
Okay, so most of the digital twins I'm familiar with have a software product that they're sitting on. How do you guys hold your digital twins? Is there an in-house kind of a model digital twin that you have, or are you using someone else's digital twin software to put your scans in?
So all of our data goes into the Looq AI platform, right? And that is the software piece of the platform. What that allows our customers or partners to do is to really act on that data within the cloud where it's located. And that is where they can, for example, do the analysis on the different data. They can integrate it into a lot of different products as well that we are looking and excited to be partnering with, and then be able to drive that end value. Right?
What are some of the common analyses that they're using with your products?
So today we're very much focused on a lot of survey deliverables, which include as-builts for actual surveyors. Think of it as blueprints that are survey certified. These include spot measurements of assets. These include break lines. These include different topographic features, orthographic views of the data that is captured with the Looq product. And then also a lot of the 3D, for example, point cloud deliverables, as well as different higher levels of semantic information around those point clouds.
You use something that's quoted as called LiMAR AI technology. What is the M there, and how would you describe it?
Yeah, so it stands for light matching and reconstruction. And what this means is that we're using actual pixel matching for every image that is reconstructed. And what's unique about Looq is that we've developed the algorithm, which was originally known as photogrammetry in the 80s, at a scalability speed point that today makes it accessible, right? And we also made it reliable. And if much of the audience will know about the reliability issues that we have around photogrammetry, doubling, misalignments, noise issues, right? Looq has taken care of that, right? So we don't want users to think that they need to go in and have expertise into manual data processing, because we really are a one-stop solution for end-to-end data capture into analysis, into intelligence.
When you say you've taken care of it, can you be a little more specific about what you mean by that?
Absolutely. So part of our algorithms have a lot of self-consistency checks, right? We really ensure that the reconstruction is reliable and is correct, right? And that has the unique advantage that we build that trust from our data quality all the way through our product to our customers.
Okay, so our audience is a lot of civil and structural engineers. So how is this something that they might be able to use to do their jobs better, and why would this be maybe better than what they're already using?
Great question. So we're really excited about supporting a number of industries in the future. Today, with our initial focus, we're heavily in the utility space, but that includes a lot of road surveys for topographic measurements and surveys that are used for downstream applications, and any civil and engineering task downstream relies on having a model, that true as-built of that environment, and that's where Looq comes in. How do we increase that value? Well, we make it the single easiest and fastest way to collect that data in the field, repeatedly at scale, and have an end product that is intelligent for the different applications driven down from it.
Could you describe a few very specific use cases that have been already used, some areas that you might think that this product might be working very well but isn't quite being used just yet?
Yeah, absolutely. So as I was mentioning, we're very focused on the electric utility space as initially before expanding into different verticals. Part of our applications there are, for example, in the distribution and transmission space, right? So now engineering companies can go out and capture, I'm going to say, citywide asset information, statewide asset information across different areas that fundamentally need ground-based access. So they have crews going out, capturing that data by foot, and very quickly turning that into these intelligent digital twin models that then power downstream applications. For example, on the distribution pole side, right, our software can automatically extract certain attributes and features that are used for structural load analysis, right? So that's a great example for one of our use cases. And beyond that, right, the same data goes into topographic surveys, right, for surveyors to use, and then also into asset management databases, right? So now a single pass of data collection can serve multiple downstream applications.
What kind of feedback do you get from customers? What do they, what do they like most? Is it the camera? Is it the AI part of it? Is it the simplicity? What are some of the things that you hear back that they like about this?
Yeah, no, all of our customers are incredibly excited about the speed and ease at which they can capture, right? So traditionally having to set up a total station to, create an as-built of a transmission tower used to take 3 to 4 hours, and with Looq, they can do it in 45 seconds. So being able to have nearly anyone on their crew do the data collection and have the trust in the data to be able to know that it's survey grade allows a lot of applications downstream and saves their bottom line value, right? And that's what Looq is really driving. The other second part, which I think they're most excited about, is the downstream automation. And that's where we take a lot of pride in, is making sure that the data we deliver is noise-free, is geo-referenced automatically, is perfectly scaled, right? And being able to deliver that to their end clients means that they have better trust, they have better communication, they have better bidding advantage. And we're all after supporting our customers to succeed.
How do they feel about your digital twins? I know that just most of them, there's all these software companies that have been doing this for decades. Do they feel that it's a comparable as far as the digital twin quality and what they can get from it and how they can use it over the lifetime of these assets?
For the first time, I think, ever has it become accessible to create digital twins at the scale that these engineering companies need and utilities, so that they can enable the different downstream applications, right? Let me use an example, right? In the past, they would send out a surveyor to do an as-built. They would send out a field technician to get the measurements for their engineering design. Then they would send out someone with a clipboard for the asset management, right? Now, with Looq's digital twin solution, that allows them to automate these different parts into a single survey. Right? And that's where there's a lot of value being driven downstream processes.
Okay, you may have already mentioned this, but what are you looking forward to most next? What's your next big focus?
Well, the biggest focus is really making sure that we are able to demonstrate that data quality at scale with our different customers, right? So we're expanding in the industry to be able to support the workflow from surveyors into the engineering companies, into utilities. So we're excited about a number of upcoming releases that you'll be hearing about that will really facilitate and emphasize what those downstream processes are and how we can help these different collaborations, companies work together to really succeed in building a better, safer world.